idea was if you throw mass resources at a problem, it could be solved quicker, was how it was adopted in the business world in modern day as well as in software. So aside from being a politically incorrect, quote unquote, possible term, talking about Mongolian hordes, it's actually something referred to as Mongolian horde theory, modeled after Genghis Khan and the horsemen of a Mongolian army.
Wow, okay.
There you
All right.
go.
Well, thanks for joining us. Let's move on to the next slide here. Just a little bit about PNSQC first. We're in our 36th year. Our conference is held every year in Portland, Oregon. We're a nonprofit organization. It's run all by volunteers, including myself. And it's great to have, each year we have a big range of topics and speakers. And this year we're having Michael come and talk to us, not about Mongolian hordes, but he's giving us a keynote talk as well as a workshop. So let's move on to the contents of the webinar here, Michael. First of all, some little house rules. All of you are muted, but we will be sending you information on the recording as well as the slides, and you can also ask questions throughout the webinar in the chat panel. So, next slide, Michael. Yeah, my name is Phil Liu. I'm a board member at PNSQC and also the program chair this year in developing the program. And I was lucky enough to get Michael in time as far as nailing down his schedule to do the webinar for us, as well as be an invited keynote speaker. So let's introduce Michael. When I saw your description, Michael, of your resume, I put some stuff in blue there because I think that those things are very important. One of them is that you're the director of the benchmarking practice at Cutter Consortium, which is a pretty big outfit, does a lot of research, and I've read a lot of those publications, and they're really, really deep and good. So I invite all of our participants to take a look at that, some of those publications. And I also see that you're an expert in measuring and estimating and managing software projects, which seems to me like it's a pretty broad thing to do. What kind of things do you guys measure, would you say, or most people interested in measuring?
Well, right off the bat, quality. So there's an adage that says J.D. Power and Associates had single-handedly transformed the auto industry just by measuring things like initial quality of a delivered automobile, and by including that metric as part of the whole conversation about automobiles, the entire field was transformed. So measuring quality in software is certainly a parallel to that, and quality conferences like PNSQC, I'd like to think that we are transforming the software industry by talking about what we see in quality measurements. So across 13,000 projects that we've been measuring year over year in the past 25 plus years of our research, we have some interesting patterns. And patterns are what we're going to talk about today through storytelling, through what we're seeing, small teams, large teams, varying degrees of complexity, team experience, and that gives us some insight and guidance about what we choose to do. How do we respond to the fact that we know these patterns exist?
Yeah, I see that you have 25 years of experience, but we won't talk about how old you are.
Oh, don't, please.
But one of the other things, it says dynamics of teams, and I guess there's a different dynamic when you have 1,000 people on the team versus 5. And that brings us kind of to our subject today. So I'll just let you take it away and keep talking, and I may raise my hand and represent the attendees and ask a question as you go along.
Great. Sounds like a plan. Are we ready to go?
I think we're ready.
Okay, let's go. Thank you, everyone, and I appreciate the fact that this slow internet connection in Mongolia caused us to have a little bit of a delay in getting started, but nonetheless, we're good. Actually, I'm in Western Massachusetts, and blame it on Spectrum, also known as Time Warner. So with that, I'm excited to share with you a prelude of just some of the things that we're going to focus on in this exciting conference. I didn't know that PNSQC had a 36-year legacy of having this conference in the Pacific Northwest, and it's a privilege for me to be back. I'm a past keynote speaker and workshop leader at the conference, and it's always a pleasure for me to be back among family. So let's talk about what we're going to be addressing today. One of the things that Phil talked about is the dynamics of teams. Small teams of pair programmers versus the possible old days of throwing large resources of people to get a problem solved. We've seen that in our database in QSM, which stands for Quantitative Software Management, or managing software by the numbers, for that exciting phrase, QSM. SLIM is our database, which stands for Software Lifecycle Management. So we look at things about the software lifecycle retrospectively on completed projects. We also look at, from those patterns, can we predict how a project might behave? The past is prologue. And we also talk about how do projects perform in flight. So they've departed the gate, to use an aircraft analogy. They're climbing up to cruising altitude, and what do they exhibit as they're on their journey before they arrive at their destination? So that's what's considered the life cycle, the full software life cycle. Projects that are about to launch, the ones that have launched, and the ones that are completed. And they represent a number of different kinds of projects in the world. They could be waterfall projects predominantly. They could be more agile. They could be in-house. They could be outsourced. There could be projects that are predominantly maintenance, or refactoring and technical debt, or brand new development from a fresh sheet of paper. Those are the kinds of spectrums of projects that we've seen enter our library of data in our database. And at Cutter, I used to publish and write what our observations were, including in the quality dimensions. So I'm happy to talk about what we've seen. So with that, what kind of data are we talking about? What kind of companies? Well, you name it. Obviously, it reads like a who's who of Fortune 100, 500 type of companies in different industries. So there are many things that we observe that are different by industry. So real-time embedded systems for satellites behave very differently than systems that would run billing in a hospital, or banking and financial services. But nonetheless, there are a number of different patterns that we like to share in our research, and we're about ready to do some of that today. Now, in a previous life, I actually was on a project that was a real-time navigation system for undersea vehicles, specifically the Trident nuclear submarine. And one of the things that was involved in building the code for the gyroscopes and the inertial navigation and the satellite resets and the velocity measuring sonars on this ship was a highly complex body of software across 6 major subsystems. And how I got into the field of quality was on addressing bugs in code for a nuclear submarine. And I can tell you that if there's severe bugs that cause major errors in flying a nuclear submarine under the ocean, among undersea mountains and valleys, and you have navigation errors and you crash that ship, that's a really bad thing. So we were very much focused on quality, and some of what I'm going to share with you has some origins in that research. Now, interestingly, back in the day when we were building the code for this, it was under what was a DoD military standard software process. But I'll tell you something, it's not too much of a secret. I've been sharing it for some time. We arranged all the folks in one large co-located room. We had them work in pairs. We had them single task. They were not doing multiple things at once. They were solely working on this navigation system. And we gave them the best tools that we could afford at the time to be able to build the code. We also wrote tests before we wrote code. So now you might actually hear some familiar things that predated what's Agile that in many ways this team was Agile before Agile was cool. Pair programming, test-driven development, co-located teams. The only thing we didn't do was build software in 2-week iterations, because that just wasn't the way this system worked. We did build systems in iterations, but that's a different story. But from a quality perspective, we saw that bugs exhibited a certain shape. They exhibited something called a Rayleigh shape, named after a British mathematician, build up to a peak and then a long tail. Now, interestingly, this Rayleigh shape can either be long and tall, or it could be very short and it could have a lower magnitude, lower peaks. There are many things that drive the shape of this bug curve, and if you take the integral of this rate curve of bugs occurring over time that are being tracked by severity, you get the sum total of the number of bugs. So we're going to talk about today about what do bugs and defect rates look like, what does your quality culture reveal when you're working with anywhere from pair programmers and small teams to Mongolian hordes. So let's talk about those two. Let's look at pair programmers. So this is the view that some of you may even be familiar with about people working in pairs, teams of two. What Kent Beck in extreme programming would refer as XP, okay? And this environment adopted pair programming very early. They also worked in small teams. There are a number of ways that you would look at that pictorially, and here's one. This is a story phase sketch on a timeline where the vertical is the number of full-time equivalent staff. So the story phase in green there, you'll see it's about 2 folks starting in March and moving across the timeline. At some point in the end of May, the project goes into its first build iteration or sprint from 4 people to 8 people, for the most part staying at 8 people all the way across for several months, about 11 months, finishing in May of the next year. So this project is called Mobile Encrypted Swipe. It was an Agile project of pair programmers, and it's if you swipe your Visa or MasterCard through a Square device on an iPad when you're buying your Starbucks coffee, okay? It had a certain number of stories in the backlog, which is in the lower left. Right in the middle, there were a certain count of bugs that were found during testing before it was actually deployed. Now, if you look at that number, you'll say, oh, 61 was the total. Now, you might think, is 61 a low number? Is 61 about an average size number of bugs? Or is 61 a higher number compared to, say, what might be the industry norm? So that's the kind of question that we typically ask ourselves when we look at defect or quality results from something like team size of pair programmers. Let's look at this next, Mongolian Horde. Mongols in the northern China, between Siberia and northern China, often were tall horsemen. Interestingly, when I look at pictures of my grandfather, my father's father, who was over 6 feet tall, some of us in our family said, hey, maybe grandpa was Mongolian. Who knows? But the idea of Mongolian horde theory, like I said, aside from being perhaps viewed by some as politically incorrect, actually was a business theory. It's a concept or technique that says that if you throw mass resources at a problem, you can solve it quicker. It stemmed from the old idea about Genghis Khan, who would attack a village with speed and size and take over a village quickly and efficiently. Businesses adopted this idea about moving in and solving a problem quickly with large teams. We saw that in some of our research in the software industry. And so here's an interesting sketch of what was essentially a Mongolian horde, quote unquote, of up to 95 people on a project. Now, when I sketched this out at this medical systems company, I looked at what I had drawn from the narration of what they were telling me. They said the concept phase is in the beginning between March and July, and that's in blue, and we're going to lay out the the system requirements, the business and technical requirements in green. That's about 50 to 60 people ramping up very aggressively in 2 to 3, 4 months. So there was even a mini Mongolian horde there. And then we're going to hand it to this large development team that's going to ramp up very rapidly from 730 people all the way up to 95 people in 4 months. I mean, literally throwing an army of people at this project. And I said, well, why so aggressively front-loaded on the front end of this build phase? I mean, look at how aggressively that ramp-up of people is. And they said, well, we're trying to make a date. And I said, okay, that's a very aggressive ramp-up, probably among the most aggressive that we've seen. In our database, a typical ramp-up for a project of this size is about 40 people. You're more than double. If you exceed that and go to 100 people, you might be 2.5 times the norm. They said, that's right. You know, speed is what we're seeking, trying to attack this problem with a large mass of people. So I immediately said to him, to the senior vice president, if I'm trying to compress schedule by throwing a very aggressive, like doubling the team size on a problem, do you think the bugs in your code will go down if you got a chance to do it twice through a time machine? Or do you think they'd go up? And they said, well, I think they'd go up. I mean, that kind of makes sense. We're trying to really push the envelope here in terms of speed. I said, yeah, they pose a very high risk of going up. Would they go up by a factor of twice or 3 times or 4 times, do you know? And he honestly said, I don't know. And I said, okay, hold that thought. If your bugs climb through the roof from this very aggressive compression of schedule by throwing a lot of people on it, where do you think they'd show up? In testing, right? I said, yeah, they'd show up in testing. And I said, well, take a look at during your testing, are you ramping down or are you ramping up? And he said, well, clearly from that sketch of what's our staffing plan, we're ramping down. And I said, okay, so let's just think about the quality risk on that and what you're putting your QA team through. If they're under so much pressure at maybe having to clean out the code and they're faced with a large number of software defects and they don't finish, what happens to them, right? So we don't have to go all throughout the whole history of this project, but what I wanted to illustrate with this is the issue of bugs. So in that case, the quality culture was certainly revealed in a de facto way just by reading how they staffed, whether it was a small team of pair programmers or the Mongolian hordes. So let's think about that for a minute and take a quick look of a chart that shows projects side by side. Where on the left, we've got pair programmers that are smaller releases that are smaller, more frequent delivery. The amount of code and the number of stories is a more manageable, smaller size. On the right, we've got projects on the Mongolian Horde spectrum, and this is a chart of defects found during QA and regression. The solid black line running through the middle is the data from the QSM database of 13,000 projects, where we plotted all of the data for only medical systems on a trend, and then plotted this company's own data against the peer group and determined visually and numerically whether they were below the industry average, that solid black line, or above. And you can see that if I look at the pair programmer projects on the left and I draw a line through the red dots, I might actually be able to observe that the data is showing that there are 50% fewer defects in the code compared to the center industry average, which we would get if we did a red regression line through that little triangle constellation on the left side of the graph. If we drew a line through the right side of the blue dots of the traditional Mongolian Horde projects, we can see that they're twice, if not 3 times, the industry average. So now we're seeing a cause and effect. we're seeing that where we have smaller teams of people working in pairs, we have about twice the quality, half the number of bugs in the code. And in the same company, in the before scenario where they used more of an aggressive Mongolian Horde strategy, they had 2 or 3 times the number of defects in the code. Still within the same company. The only difference here is how they staff their projects. Because in some cases, the people who are on the blue square projects were the same people that were on the red square projects. They're just in different time, red circle, excuse me. So even inside one company's culture, by doing it 2 different ways, we saw a different consequence of how they dealt with the time pressure problem, with speed. And so in one case, they decided, let's build high valuable increments of more frequent, smaller release delivery in the left scenario. And in the boil the ocean, one large project with Mongolian Hordes, time pressure being very aggressive, let's build it the way we see on the right. So let's take a look at some data from another company. I'm going to switch gears. This is also a pair programmer environment where there's a certain number of projects represented in this data sample, and we took the overall pattern of the average. So for the average release size for this company, I posted the industry average cost, schedule, defects in QA, and the headcount staffing in that first column. 3.5 million, 12.6 months to build that, 240 bugs during QA testing, and the team was a staffing headcount of 35. This company was building that amount of functionality for 2.2 million instead of 3.5. So they're 1.3 million cheaper than the industry average, and they're building it at 5 months, almost 5 months faster, 7.8 months instead of 12.6. Only 121 bugs found during QA and regression, which is a full 50% lower than the industry average with the same headcount team of 35 people. So interestingly, what we found here was they got speed under 8 months compared to 12 and a half by working in pairs using an XP approach. And I'll say that when I asked them, I said, what do you attribute to your finishing so quickly? They said, well, we found that by pairing people in twos, we were able to have a high rapid transfer of knowledge between the 2 working pairs. We found that there was an idea of instant code reviews. So like a pilot co-pilot, they were instantly checking each other's work. So there were fewer mistakes made to begin with. So the code was actually cleaner to begin with. So by the time we got to testing, they actually didn't have as many bugs as we expected. And so we got schedule. So let's think about this for a minute. In the Mongolian Horde idea is you rapidly build the code as fast as possible with an army of people, and then you test the bugs out. This turned it on its head by using people and building the code with quality first, and then you get the schedule. So it literally flips it around. Interesting. And because the project is finished almost 5 months faster, on a project basis, the cost was 2.2 million instead of 3.5 million. And I say to my clients, you know, when we look at trying to solve problems like this, we look for $1 million. I say, I want to find from the research, from your own data, ways to find at least $1 million. And then if, you know, we get that 2, 4, 6, 8 times in a given year, now we're talking about a real pile of money. So in this organization, by consistently being able to build projects on average of 1.3 million less, for about 6, 7 releases, they were building systems for $7, $8 million less cost for the entire team over a given year. Remarkable. Now, the CEO also asked for another chart that said, what do the Mongolian Horde projects do for the same class of work for the same size? I said, okay, let me pull that up in our database and see what the data tells us as a story. I said, we actually see that instead of 35 people, the average team size is 50. So plus 15 head count there. Yes, they get it done faster, more people. They compress the schedule from 12.6 months. They get it 3 months faster at 9.6 months. But because they're using a larger team size and burning the payroll faster, the savings isn't that much. 3.2 million instead of 3.5 million, so only $300,000 less. But look at that bug number, the QA defects, 677. That's almost triple what we see in the industry average in terms of bug density in the code. So part of why they couldn't go faster than 9.6 months was because they had to spend more time in testing to get 3 times the bugs out. So let's go back really quickly to that other pair programmer scenario where they finished in 7.8 months instead of 9.6 months. So for this CEO, I said, you know what, if you decide that you're going to use a Mongolian Horde approach, you're actually going to take longer than your smaller team approach. And it's not going to cost you less. It's going to cost you more, about $1 million more per project. And you're going to have 3 times the bugs. You pick. Well, needless to say, the pick was pretty obvious, so they went with a small team paired approach instead of Mongolian Hordes. So a wise choice in this case. So let's take a look at what may be going on behind this mathematically. So I've illustrated the number of communication paths for, say, a hypothetical team of 4 on the left side of the chart, 4 little blue circles. And the question in knowledge work as we're working as a team and solving a software or mathematical or a technical problem is they have to share ideas, brainstorm among themselves, and talk amongst themselves. And so how many communication paths are there in a team of 4? So we would draw the lines across all 4 of the squares and then the 2 diagonals, and we actually get 6. 1, 2, 3, 4, 5, 6, right? On the right, let's say we double the number of blue nodes and we go to 8, so it's like a stop sign, like an octagon. How many communication paths are there? So if we wanted to, we could actually draw all of the connected dots, and then we can count up all the lines.
Michael,
And
we have kind of a related question here. Gene is asking, you know, firstly, how long ago was the project? But the other one is, what was the nature of collaboration with offshore team members? Was there was there any offshore team members? Yeah.
On the previous project of the Mongolian Hordes,
Right.
in that case, yes. So there was onshore architects, BAs, system designers, like something like this, right?
Right.
And then there was a combination of offshore on the right, in the red. Now this is different from, say, offshore testers versus offshore developers or a combination of that, but let's hold that thought.
Right.
And in some cases, there are charts that are like this that are onshore Mongolian Hordes. So it's American Hordes, right? Or whatever. And it's not just where they're located, so let's hold one variable at a time. It's just the sheer number of people.
Right. I think, you know, a subsidiary question was, you know, if you have a Mongolian Horde, you know, what if you were to use more advanced tools in communicating? Because from your previous graph, which showed, you know, the number of lines of communication and how that pretty much complicates things, you know, what can we do to alleviate that situation via more advanced communication tools? So
hold that thought.
Maybe that's an auxiliary question. Yeah.
Great question. Great question. And that's exactly the kind of question that I would pose when we're looking at the rubber band ball on the right. So because the sheer mathematics of the communication paths on a team of 4 being 6 and a team of 8 being 28, how do we now mitigate the fact that we've got more complex team communication on the right? You would naturally ask that. Is there a way for us to break the team of 8 into, sub-teams of, 4 pairs of 2? And is there a project owner, a product owner, or something like that? Do we have other ideas about minimizing communication mistakes by having a sprint review, an iteration planning meeting, daily stand-ups, right? An iteration or sprint retrospective after 2 weeks or something like that. So what are the things that we could do to mitigate the fact that there is a mathematical fact of communication paths increasing with a linear increase in team size? So let's just look at this for a minute and hold this in isolation. A team of 4, you double it to a team of 8, the number of communication paths increased by a factor of 4. So it's nonlinear. And there's a simple mathematical algebraic formula for this. You take the number of nodes on the team. So in the case of a team of 8, you multiply it by n minus 1, which is 7. You get 56. You divide 56 by 2 to get pairwise communication paths. You get 28.
Gee, so I think you did go to college.
I did. I studied sixth grade. I studied 6th grade algebra.
Okay.
So now we have this simple revelation, and actually Dr. Robert Tausworth of AT&T Bell Labs once published a paper about communication theory and software engineering, and he talked about exactly this kind of graph, that when we look at the data of the number of defects plotted as a function of the X independent variable being the number of headcount on the team, we find that with each doubling of headcount, we see the sheer number of defects in the code rising by at least a factor of 4 and sometimes as high as a factor of 6. So there you go. It's right there on a simple diagram of a square with 2 diagonals and a stop sign with, looking like a rubber band ball. So that's the basics of what we're dealing with when we throw a lot of folks on it. So now we decided, well, let's take a look at data for different communities of developers with varying team size. So some time ago, as a keynote speaker at a conference in Columbus, Ohio, and I talked about what we were seeing in measurements, talked about how schedule pressure was being revealed, on how companies were responding with aggressive or conservative staffing. We talked about what we were seeing in terms of bug patterns and things like that from all of our benchmarks, all of our measurement over the years in our research. And Columbus, Ohio said, hey, we think we're like the Silicon Valley of the Midwest. We think we're like a real bunch of Top Gun pilots here who know how to build code. We'd like to do a benchmark study and pool all the results and see how we do against the world. Columbus against the world. Maybe there's a Helen Reddy song that says like that. You and me against the world. Sometimes it feels like you and me against the world, Columbus, Ohio. So we did a study. Later on, when we reported this study in Europe, saying what we found in Columbus, Munich said Germany is really at the forefront of engineering. We want to see how we do against the world, and we want to see how we do against Columbus, Ohio. And then I said, well, I could be creating an international incident here. Munich takes on Columbus. Maybe we'll have the coding Olympics in terms of quality. So we did a little study. Let's take a look at staffing versus defects for Columbus and Munich. So here is a chart of not to defects yet. Each of these little green squares are projects plotted for small, medium, large, going from left to right in terms of the size of the backlog. So you might have a small release that was, only about 42 stories. Certain number of story points. Medium-sized projects could be 80 to 100. Large projects could be 100 to 200 story points, new and modified code. use cases, use case scenarios. So we're looking on the x-axis of a measure of the volume of the release of the delivered functionality, going from left to right. On the vertical here, we have the number of folks, head count of the team. So 3, 4, 5 people on the left. On the right, you can see that we're those little 2 dots on the upper right might be about 20 some odd folks for the average staff, and then somewhere in between. So it's clearly anywhere from 3 to 20 folks in terms of head count. When we plot just the head count against the trend line for staffing, we find that there's a whole body of projects that simply hug the center lane of the highway. And then there's a cluster of constellation on the upper left that's 2, 4, 6, 7 projects that are hugging the +1 standard deviation larger head count side of the trend, which is what those dashed lines are. It's like the sides of the bell curve. Larger teams tend to be on the upper dash lines, smaller teams on the lower dash lines. So that's plus and minus 1 standard deviation for you statistical techies out there that would look at a regression chart. So, okay, so that's the staffing for Columbus. Let's look at the staffing of the projects for Munich, Germany. Bink. Okay, so now you're looking at a predominantly body of data that also hugs the lower side of the standard deviation, a few projects that are close to the middle, and one that's on the upper. But predominantly, if you eyeball it, the constellation of those project stars, all but 3 are either at or below the average for team headcount. So the Germans were tending to use smaller teams, generally speaking. Let's look at the bugs for Columbus. My goodness. For the most part, all of the data for the number of bugs found during QA and regression were hugging the lower line and even below. But overall, we can see they're in the -1 standard deviation or better against the industry database. All of them are below the center average. In fact, if I took the overall average of the number of bugs compared to the industry, there's 75% fewer. So for every block of code where there might be 100 bugs, on average the Columbus community was only seeing 25. Pretty good. The Munich teams, not bad. There's a whole, I could read this a couple of ways. I could say all but 3 of the dots are below the industry average. There's only 1, 2, 3 that are either at the average just by a smidge or a little higher. But for the most part, also the predominant pattern is there are more projects with fewer defects in the code than the 3 or 4 that are on the average or above. So maybe 2/3 of these projects are lower than industry average for bugs in the code. But nonetheless, Columbus, we'll go back for a minute, is faring better. Munich, not bad, but not as, score 1 for Columbus. So it'd be interesting to say in this case of the software quality Olympics, the gold medal goes to Columbus. Even though Munich tended to use smaller teams. So then we got to the point of looking at experience in this particular transformation into more agile methods, and it turns out that sometimes larger but more mature teams in Columbus outperform smaller but less experienced teams in Munich. So now we got another variable about team experience, mature teams versus teams that are trying new methods for the first time. But overall, for the most part, we see a correlation with bugs and team size. So we took this on the road and shared it with a number of conferences over the last 10 years, including conferences like PNSQC, where I talked a little bit about some of this in previous talks. So I'm looking forward to coming back to Portland in October this year. And this is a summary of just the Agile body of data. They tended to see 75 fewer defects in terms of defect density in their code and 30% quicker schedules. So for every 10 months of schedule, they were seeing 7. For every 10 weeks of schedule, they were seeing 7. And Ken Beck would say, you know what, if we're seeing things work, we should see cleaner code and shorter time. And that's what we saw. So that's an interesting lens through which we can look at, from pair programmers to Mongolian hordes, what do we see in terms of quality? So this is a point where we transition a little bit in the presentation and say, okay, maybe we're building code in an efficient manner time-wise, and we're building clean code, but what are we building that matters? Are we building stuff that matters? And so we're going to really touch a little bit on the idea of value, because if you build something fast with clean quality that nobody cares about, that's a less successful project than something that is a real game changer that you're building with high quality and faster schedules. And a game changer, something at high value, is something that we ought to be thinking about. So how do we take ideas about business agility, say, from a standpoint of the quality results from software engineering agility? So if we're getting good quality, can QA professionals also advocate for value? And I say yes. I say that a lot of folks that are on the business side, BAs and QA, collaborating as a team, may want to create for the marketplace things that make more money, increasing or improving revenue, increasing efficiency and avoiding costs, or perhaps in a third dimension, changing the experience and improving the experience, improving service. And so what would that look like on a scale of some kind of metric? I think that if we index things along those lines, that will be something that's the next frontier. So not just indexing complexity of what we're building or the size of what we're building, but the value of what we're building. And this way we can sort in the parking lot like valets what moves to the front of the line. And I think that if we proactively take a stand on this kind of an idea, we increase the value of us as QA professionals to then be able to contribute more to what our teams are building, not just in terms of getting the bugs out, but building what the customer really wants. And so if we do that effectively and we think about the outcomes that our clients are looking for, and we want to deliver not only a high quality code to our business, but high quality experiences with associated benefits and certain business outcomes, the scope of those projects that we actually take on should be reflected in terms of what kind of outcome and value that our customers are looking for. And this is an area that I think as QA professionals, we can contribute to saying, you know, when we're building a release and we're laying out the, you know, staffing for the story phase in the lower rectangle and the build phase and then the QA and testing in the larger rectangles, say across between February and July, we're trying to define what goes in that box, in that, you know, time boxing. And here's where I think that we can actually have a voice and have a stakeholder position that says what should go in that box. So I'm going to talk a little bit about that in my keynote speech as well when we get out to Portland, because in the scheme of, say, you know, a scaled agile framework, you know, one of the things that we're going to be thinking about is, you know, exactly how are we going to respond to change on the inside? Because the opening line of my talk is, if change on the outside exceeds your rate of change on the inside, the end is near. You're in trouble. So I'd like QA and engineering professionals to be more adroit and adept at being proactive at driving change inside our culture so that we can create systems that matter. So as we wrap and then we leave some time for questions, I want to leave at least 10 minutes, a quick run through some things that are practical advice. Now that we know what we know, what are some fundamental truths? Well, one is we're in the knowledge work business. And where possible, if we are able to retain the smartest folks and most experienced folks that we have in building a high quality team, that maps directly into quality of the code. So less experienced folks, as we saw from some of the data, can result in more errors and more bugs in the systems that we deliver. Inexperience not only costs money, but it costs in terms of building systems that work really well. So domain knowledge is critical. Short feedback loops is really the epitome of pair programming. If I'm flying my Piper or Cessna plane, which I do, I'm a private pilot, really aviation is one of my passions. I find that if I'm paired with an experienced pilot and we're in the cockpit of the plane, we're going to really be on the ball, and two eyes are better than one. There's an instant review from one person to another. We accelerate the learning of what we're doing and we execute better, and we have face-to-face communication. So short feedback loops are really valuable. And when someone asked about whether we have dislocated versus co-located teams, that's a longer feedback loop. So how do you possibly mitigate that? Possibly with technologies, and in a lot of cases, technologies are not a cure-all, okay, although they help. It's nice to be able to have Skype. It's nice to be able to have virtual conferences, but it's not always the same. Avoiding burnout. A tired mind is an ineffective mind, and we find that when people in Mongolian Horde projects often or whatever are overworked and they're exhausted, they tend to write buggier code. And then we have to do it over. Transparency. If things are hidden and locked away in cabinets and deep into files and we can't get at information quickly, that's a problem. And one of the things about software development is we find that transparency really is a key factor in success. And that helps with high bandwidth communication. The best teams have wide open pipes. Domain knowledge moves rapidly among a team. We are in the knowledge business, and when knowledge flows, all good things happen. And this is something that a lot of people might find counterintuitive, but quality is inversely related to quantity. So if you get really greedy and you try to pile the backlog too big and there isn't an open space to move the pieces around, you can't solve the puzzle, you wind up with more bugs in the code. So I say, at least in the outset, build a little less. Don't get too greedy. Don't hoard, to use the other spelling, H-O-A-R-D. Don't hoard your functionality and overreach, because then you might be tempted to use a Mongolian Horde to make the date. And so as we close, and then we'll open it to questions, what about you? We had this fun exercise when we tossed out to Columbus. What if we as a group took a look at our data and maybe we contributed data anonymously, changed the name to protect the guilty and the innocent, and did a plot of what Portland's projects would look like, or the community of the PNSQC community? What would your defect trends look like versus staffing? So hold that thought. Maybe we may want to know thyself, because in the scheme of things, if we don't have metrics, we're just guessing. We're just people with a different opinion. And so I'm going to close on that. And I've given you a lot.
Thanks very much, Michael. We had a couple questions come in over the last few minutes. One of them was, which you kind of addressed, but not quite. You had talked about, obviously, smaller teams have less errors, and corollary to that was, well, if you're going to have a smaller team, then maybe you need to think about having that team develop what's most important in terms of reducing the features and making things smaller. But this question is, how do we include remote workers? And Gene asked this question a little bit earlier in terms of technology being used and so on. And what have you seen in terms of how to handle this? Because Agile is all about being co-located, blah, blah, blah. But in reality, that's just not the way it works.
Right.
So what's the best way to include remote workers or people in different locations? I mean, millennials don't like to go to the office, right?
Right. So that could be a good and a bad thing. And the quick answer that I would say is let's see what your data shows. So if we did a little sketch that included folks that were in the office but also non-co-located and drew the head count over time and charted the bugs, we could also look at when we have more or less of that and see if there is a causality or correlation to fewer or more defects. The teams that I started working with in one of my clients that over 10, 12 years, we've got measurements across all kinds of projects. They would work in some cases with, remote teams, people working remotely, telecommuting and things like that. Could it be done? Yes. Yes, absolutely. It's not absolute a requirement that you have everybody all in one room. Sometimes you can't get the most highly experienced people all happening to live in Chicago, Illinois, or Portland, Oregon. So to the extent that we can mitigate the distance and the dislocation, that's where the magic pixie dust lies. The trickier part is when you cross time zones, okay? So now if you start really pushing the boundaries there, where 8 o'clock in the morning for you is 5 o'clock in the afternoon for your colleagues, and they're already thinking about dinner, that's when collaboration is more strained. And so my answer to that is it depends. It depends on what you're building and it depends on the delineation of what the work is. Sometimes remote and dislocated testing works just fine, because we're building the stuff during the working day and then we're handing it off for testing when people are on a different shift. That's different, and it works. So my quick answer is let's see what your data says.
Yeah.
What about you? And we can do that.
I think, when somebody calls me and I'm having dinner, I don't even answer. But anyways, there's a couple more questions that are related that we can answer in the blog. One of them is that have you discussed this with Rich Sheridan, who came and did a keynote for us last year? He does a lot of pair programming and small teams as well. I don't know if you know Rich, but if you don't, I'll certainly make the introduction. The other question is, how much do remote workers impact the overall productivity on average? And I guess the question kind of is assuming that remote workers decrease the productivity, and is the decrease worth it in having the additional manpower? Maybe that's kind of a biased way of asking the question.
Well, I do think that there's trade-offs, and I think that what we ought to really know is that when we look at what the numbers and the data says, we actually see the degree of the trade-offs, because without metrics, the trade-offs are an opinion, right? They could be just speculative. So I'd say, again, it's not too difficult to do. We know how to measure quickly. We know how to do it in a very efficient way. And let's take a quick look. Sometimes it's as simple as something like a quick blood sugar test. If you got a trace of diabetes, you can find out some results really quickly. You don't need a full workup. So for people who have those kinds of specific inquiries about their own deeper cultural dynamics, talk to me. Come on out, grab me on the side. We can even grab a corner and a soda and talk about some specific issues. But definitely there are solutions. It's not all problems.
Great. Can you go to the next slide? I have something interesting to announce to the folks. Yeah, so a lot of you have been asking about the webinar being recorded. Of course, it's being recorded, and of course, we will share it with you. Michael, thanks a lot for really giving us all this information and sharing with us your knowledge over the past, not only your personal knowledge, but also all this data that you in your company have been able to collect over, thousands of projects. So that really makes a big difference. And lastly, which I think is important, is we're going to have everybody that was attending this webinar, give them a discount code. The discount code is called Ma webinar discount.
Oh, I love that. I love that.
And it's not Mongolian Horde discount, it's Ma webinar discount. And, when you register, just put that in the promotional code box, and in the comment box, write that you're getting the super early bird discount. And then under payment, you say check to follow, and then you'll get an invoice from our administrative folks in the office. So thanks everyone for attending the webinar. I hope that you utilize the discount, and we hope to see you on October 8th through the 10th. And we'll be sending you information on the recording. So thanks, Michael, and thanks everyone for attending.
Thank you, everyone. It's a pleasure and a privilege. And I love that you get a Ma webinar discount. You get a special price from Michael Ma. Okay, folks, thank you very much.
Thank you, Michael. Bye.
Bye.